All right, so day 2. First steps first is we're gonna give you these. I'm gonna give you these, in little steps. So I'm gonna give you 1, 2, and 3. So please pause as I go, and then we shall talk about it. Okay, so here's number 1. So pause. Here's number 2. And finally, here is number 3. Oops, sorry, too far. Okay, so what this information is saying is we're going to pick some critical number, which we just found yesterday, or in the notes before. If my function can be derived on, say, whatever my interval is, because remember, we're dealing with intervals, then we can talk about what happens at those specific points. They might be maximum, minimums, or none of the above. So if my f prime of x, so derivative of x, changes from negative to positive at that point of c, then f has a relative minimum. So that means there's a minimum point there. If it goes from positive to negative, then it's a maximum. If it's both positive or both negative, then it is nothing. So what does that mean? Well, let's take a look at these next pictures. So if you notice here, it looks like clearly I have a minimum. Colors. So on this first left side, we would consider this to be decreasing. So I'm decreasing. And on the right side, I am increasing. So when we're looking at our little charts that we make, like what we did yesterday, if you see a combination of D then I, then that point there in the middle has to be a minimum. Okay, let's talk about the second one. If you notice, this part here is increasing, so it's an I. And this part to the right is decreasing, that's a D. So if you see the combination in the reverse, so I then D, it's going to be a maximum. If you notice the next two, now I know it has these middle parts. Ignore those for a second. Just look at this part and then this part. Well, this is increasing and this is increasing. So because they're both increasing here, nothing happens. Now, if we look at the next one, these are both decreasing. So again, nothing happens. So this is a pictorial way of talking about the first derivative test that we just wrote down. Oh, okay, so let's go ahead and put that into practice. So just like how we talked the last video, we first start by taking the derivative. So this one's got a g. Ooh, not any different. So g prime of x is equal to 2x minus 2. I take that and I set it equal to 0. Then I go ahead and I solve for x. So I move over my 2, which means positive. Then I divide by 2, so x is 1. So my critical point is at 1. So I'm going to go ahead and make my little chart. So from negative infinity to x to 1. And then from 1 is less than x is less than positive infinity. So we're going to go ahead and pick strategic numbers here to plug into my derivative. So a number smaller than 1 is 0. So if I plug in 0 here, I get negative 2. And since negative 2 is a negative number, in my chart will be a D for decreasing. And I'm going to pick a number now that is larger than 1, so 2. So if I plug in 2 above, I get 4 minus 2, which is 2, so that's positive. So that number is an increasing number. So if I go back a slide, I want to look for D followed by I. Back, not forward. D followed by I, so therefore I have to have a minimum. So where is that minimum point at? Well, we got to plug in 1. So I'm going to plug in 1 to my original function here. This is the little part that's different. So we have a minimum. Now when I plug in 1 to my original function, I have 1 squared minus 2 times 1 minus 8. 1 minus 2 minus 8, which gives me negative 9. So my minimum is at 1 comma negative 9. And yes, these are still relative mins, just like what we talked about back on day 1 or 2. But if you don't want to write rel min every time, that's fine. Just know that it's minimum. Alright, second one. So let's start first by taking the derivative. Oh my gosh, it's a different letter. We'll be okay. So this gives me 27 minus 3x squared. And when I do my factoring purposes, I always like my x squareds first. I like them in descending order. So all I'm going to do here is rewrite that real quick. So I just rewrote my order. Okay, so next we're going to go ahead and set it equal to 0 and solve. I can divide out a negative 3. When I divide out negative 3, I get x squared minus 9. That is the difference of 2 squares. So that gives me x minus 3 and x plus 3. So my x values are 3 and negative 3. So if I do my chart, I have negative 3, negative 3 to 3, and 3. So if I plug in negative 3 in my derivative, what kind of value am I getting? Am I getting a positive or a negative? Good, should be getting negative, so I'm decreasing. If I plug in a number between them, logically I'm going to pick 0 because 0 is really easy. Should see that I get an increasing number. And then if I plug in a number bigger than 3, what kind of value do I get? Should be getting a decreasing number. Good. So I'm going to have 2 different points. So I'm going to have a point at negative 3 comma something. So I'm going to plug negative 3 in to my original function, which if you want a calculator, that's fine. Go ahead and go grab a calculator, plug it in. It's going to give you negative 54. I'm going to have another point of 3 positive 54. So one's a negative, or excuse me, one's a min, one's a max. If I go D to I, that should be a minimum. And if I go I to D, that should be a maximum. So I have a minimum at negative 3, negative 54, and a maximum at 3, 54. That's all I got for you.